Hi, I'm Jennifer from Log Cabin Schoolhouse, bringing you a neat notebook so you can relax and enjoy math. It's fun, it can be easy, it doesn't have to be all problem solving. Keep an eye on the patterns, watch for the very interesting mathematicians. They can help us to discover and define math. You're about to see that it can be quite a fun adventure. And the adventure can be different every time, or you can enjoy the sameness of math too, however your brain prefers it. Ready for another neat notebook? We're going to do multiplication algorithm today. So we'll be doing 4 different ways to do a neat notebook on algorithm. So what does algorithm mean? So the word algorithm comes from Algorithmi. So he's my favorite mathematician. And let's take a look at Algorithmi. So first of all, I always like to tell my kids there are 4 different ways to do multiplication. There's 4 different ways to do addition. But why do we even talk about different ways to do these standard operations? So let me grab my pen. And first, I'm going to set up my paper because this is how we set up our neat notebooks. Neat notebook. So this is generally like maybe the 3rd neat notebook I'll teach. So we talked about the basic operators. We talked about basic addition. There's 4 different algorithms for addition. And today we're going to talk about multiplication. There's different multiplication algorithms. The word algorithm, like I said, it comes from Al-Khwarizmi's last name. And he came from Baghdad in around 800 AD. And the House of Wisdom. Now, I always like to say that mathematicians are giants who stood on the shoulders of other giants. And it's a little bit different than scientists because the mathematicians who came after, so Diophantus came first. He was a Greek mathematician, and he was the first. People would argue which one of these guys really was the first inventor of algebra. Now, the word algebra came from the book that Al-Khwarizmi wrote, so the word didn't even exist when Diophantus was on the scene in Greece. So I don't like to say that algebra was from Diophantus because the word didn't even exist then. So Al-Khwarizmi to me gets the credit for that. But Diophantus gets the credit for unknown, where Al-Khwarizmi gets the credit for the word algebra. So you can decide amongst yourselves who gets the credit for what, but we wouldn't be sitting here deciding in our neat notebook on all these algorithms or different orders of steps to do multiplication. If it weren't for Al-Khwarizmi. So Al-Khwarizmi also gave us our basic 1 through 10 numbers. Before that, we were using Roman numerals. So he was super important, and I would encourage you to sit down and do some research on Al-Khwarizmi with your kids. Super fun guy to look up. House of Wisdom is mysterious and exciting. It's a good, really interesting study. Not a lot of information out there on him, so I hope to put some information out there on my website about him. So there's more out there that people can look up. So there'll be more coming on that. So let's talk about the 4 different ways that you can do multiplication. So let's just number our paper. 1, 2, 3, and 4. And I encourage you to ask your kids before you get started, can you even think of 4 ways to do multiplication? What are the 4 ways to do multiplication? So let's see. Do I know what they're called? So let's see. Distributive property. Distributive property is the first way. So I would ask them, okay, well, what is the distributive property? And I would see who would know it. A plus B equals A times B plus A times C. So we would see who has that memorized. And then we would take a number, and let's just do 16 times 24 for our example. Oh, and my pen always likes to make that a 9. Maybe I should do 25, so I don't have all these 4s on my paper doing that. All right, so 16 times 25. So we're going to do equals 10 plus 6 times 20 plus 5. All right, and then I'm going to get out another color, and I'm going to show you with some arrows here what we're going to do. First, I'm going to take my 10 and multiply them by both of these parts, and then I'm going to take my 6 and I'm going to multiply him by both of these parts. And I'm going to wind up with, and then plus is in the middle because, oh, let's see, these are multiplies. So now I have 10 times 20 plus 10 times 5 plus, and I just have to keep going back. First I did this guy with following my arrows, 10 times 20 plus 10 times 5. Then I look at the next guy and I do 6 times 20 times 6 plus 6 times 5. All right, so now I'm just going to look inside of each of my parentheses, and I'm going to say 10 times 20 is 200. Keep my parentheses to keep it clean. Plus 10 times 5 is 50. Plus 6 times 20 is 120. Keep my parentheses. Plus 6 times 5 is 30. And now I add them all together. So 200 plus 50 is 250. And I might just do little parts. Then let's add these two. 120 plus 30 is 150. And then 250 plus 150 is 400. And then I'm going to put a box around my final answer. And now, all of that I just did was easy mental math. But if I looked up at my 16 times 25, well, unless I was really good at my 25s, which maybe I was, but most people aren't, that would have been really hard mental math. So that is the purpose of your distributive property. Now, I had someone say to me, well, Miss Jen, I really don't like doing all these parts. I would have done 16 times 20 plus 5, and then I would have done 16 times 20 plus 16 times 5. I would have just done those two, because I could have figured that out in my head. Maybe I know 2 16s is 32, and I would have done 320 plus 5 16s is, what is that, 80? Yeah, and then that would have been 400. Well, that's okay. And they would have said, but then that's not distributive property, Miss Jen, because that's not what you just did. Well, it is. It is actually distributive property. You just distributed only one of the factors. So instead of distributing 16 and 25, this idea was to only distribute the second factor, the 25. So distributive property is a really interesting way to help a person who really just wants to do the mental math, doesn't like doing all the writing, and you can find a way to do all the writing in your head, and that's fine. So go ahead and learn about distributive property. It's a great tool. Highly recommend it. All right, what is the second way or algorithm for multiplication that we learn about? Let's get blue back out. Let's see. Let's talk about the area model. Area model. All right, so let's say I have 16 and 25 again. So I'm just going to put a green box around our numbers so we can kind of use them for everything. We're going to use the same. Let's put them up here. 16 times 25. And if you do this neat notebook over and over again, the kids are going to start to learn all four of the boxes. And if you just give them the numbers at the top, they'll learn to get ahead of you, and they'll be really excited to just throw them together and get good at each of these methodologies. So let them go ahead and do that. Put the numbers at the top. This could be really fun. All right, so we have the area model. I'm going to draw a box here. Leave a little space at the bottom because there's going to be a little bit of computing on maybe the bottom and maybe to the right. So I'm going to take my 16 and make it 10 plus 6. And I'm going to make my 25 20 plus 5. All right, now I'm going to multiply each of my parts. 20 times 10 is 200. 20 times 6 is 120. 5 times 10 is 50. 5 times 6 is 30. Alrighty. And now I just add all the parts up. So I could go to the right or I could go down. And either way, I'm going to get to the same place. Let's go to the right. I had someone say to me, hey, Miss Jen, watch this. If you go to the right and then down, it's a little easier on our brain because we're used to adding down. So watch this. 200 plus 50 is 250. 120 plus 30 is 150. Well, they were right. I liked coming down with these numbers, and it is 400. Now, if I come down this way and add the parts this way, let's just see if it's the same. I get 0, 2, 3, 320. 50 plus 30 is 80. And then I have to add these parts together. And 320 plus 80 is 400. Well, okay. But I'm adding from left to right now. Maybe that doesn't bother me. Okay, so I could even do that. And look, it matched lined up right there with that 400. Awesome. Okay, so what's interesting here is I can add this way, I can add this way, no matter what, I'm going to get 400. Well, I'm going to point out that that is because addition is commutative. And I always like to point out HIP property, E-R-T-Y. So addition. So I always point out all these things to the kids while they're doing them, and that just means that A plus B equals B plus A, and if I took 2 plus 3, that is going to be the same thing if I said 3 plus 2, and I would say, right, kids? And I might even try and challenge them and say, I dare you to come up with 2 numbers that you could add in any order that would give me a different answer, and they're going to sit there and try, trust me. They're going to try and come up with a way to do that, and they're not going to be able to do that because of commutative property. But let them try because they enjoy doing that. All right, so there's 2 more ways, and these are really fun to compare. So I'm going to write both of their names out first, and we're going to talk about them. So the first one is called the multiplication algorithm. Multiplication algorithm. And the last one is called the standard algorithm. All right, and so you notice that the standard algorithm is the one that we do in the basic operations neat notebook. And the multiplication algorithm, I just think that title bugs me a little bit, simply because all of these are multiplication algorithms. And we're just going to call that one the multiplication algorithm, but whatever, that's what we do in math. So this is the multiplication algorithm out of all the multiplication algorithms, the different ways to do math of multiplication. And this is the main guy that we call the multiplication algorithm. So whatever, have fun with that. So we're going to take our same numbers, 25 and 16, and multiply them over here. And I stack them up and down. And I line up the ones place and I say, hey kids, be super neat. And over here, I'm going to write them the same way because you stack both of these algorithms the same way. And now I'm going to have us do the standard algorithm first, simply because we've already done the basic operations neat notebook. And so we kind of just talked about this, but let's do this really quick. So 6 times 5, and you might do this real slow with the kids and take your time depending on what ages you're talking to, is 30. And 6 times 2 is 12, plus 3, 15. Have a placeholder, and make sure you always say that word so they get to know it. 1 times 5 is 5. Talk super slow. The kids get really annoyed, and then they speed along ahead of you, and that is actually super awesome. Don't be competitive with them. Let them win, because when you increase their confidence, you find out that they become mathematicians. 1 times 2 is 2. All right. Now we're going to add 0 plus 0 is 0, 5 plus 5 is 10, carry the 1, 2 plus 1 plus 1 is 4. I have 400. Hey, looky there. I'm going to grab my red real quick and show us that we are actually getting the same number all around, and that is good. I have 400 up here as well, so I must be getting the right answer. And let's just, for fun, ask all the questions. What is the name of the answer to a multiplication problem? I'm going to grab my blue, and the kids are going to yell, product. I have some room on my paper here to fill, and so let's use it for vocabulary. What are the names of the parts? The kids are going to yell factor. Factor times factor, because it doesn't matter which one comes first, because multiplication is also commutative. Make the kids tell you that, because they're going to be so smart when you're done with this. Now also remind them that, hey, look, we're adding here, which makes that add. And so that makes this a sum. So mind blown that that is a sum and a product, but ultimately it is a multiplication problem. So it is a product if anyone asks in the real world, but we think that's just super cool. So we're going to say it every time we do it because it's fun. Okay, but let's do this really cool thing over here. Going back to my green, watch this. Now, if anyone has ever had a kid in public school and the kids go to school and come home and you're like, what is this math? This might be something you saw them do. Watch this. 6 times 5 is what? Oh, 30. Okay. In the multiplication algorithm, we don't carry anything. 6 times 2, no, that's 6 times 20, because 2 is in the tens place. 5 is in the ones place. So 2 is actually 20, right? Because tens place, that makes it 20. 6, what is 6 times 20? Oh, 20, I'm sorry, not 200. 6 times 20 is 120, right? So we're going to put that down here, 120. All right. Now we're looking at the 1. Wait, no, that's 10 because it's in the tens place. So 10 times 5. 10 times 5 is 50. That goes here, 50. 10 times 20. 10 times 20 is next. So 200 goes next. Oh my goodness, what is the multiplication algorithm doing to me? I have zeros, and then 3, 4, 5, so 10, carry the 1. I got 400 again. I must have done it right though. So that's pretty cool. If I don't want to carry, I don't have to. Voila, 400, no carrying, multiplication algorithm. Voila, how do you like that? So now you have it, the multiplication algorithm and the standard algorithm. That is magic. So there are 4 algorithms for multiplication here, and I hope you had fun doing it. Thanks, I'm Jen from Log Cabin Schoolhouse.